Very funny, Austin. Any questions, guys? For real question. Okay, Hussein, if you weren't here, you have to watch the lesson. Properties of parallelograms was the lesson. Okay, I'm going to move on. We're going to talk a little bit about how to prove that a quadrilateral is a parallelogram. So we've done this in other units, right? We've proved that triangles are congruent. We've proved that triangles are similar. A parallelogram has 5 properties. So you might wonder to yourself, do you need to check all 5 properties to prove that it's a parallelogram? Do you need to make sure that opposite angles are congruent, that opposite sides are congruent, that the diagonals bisect each other? Do you need to check all those things to say for sure that it's a parallelogram? And guess what? The answer is no. There are certain properties that you can check, and if they are true, then you're done, and you can prove the quadrilateral is a parallelogram. So let me give you the checklist of properties. This checklist is going to look just like your notes from Friday, and you're going to be like, why am I writing this down again? Because this looks like my notes from Friday. But I do need you to write it down, because these are the things. Here we go. These are the 5 things that can prove a quadrilateral guilty of being a parallelogram. So let's go over each of them. If both pairs of opposite sides are parallel, then you are done. You have proved that the quadrilateral is a parallelogram. Both pairs. If both pairs of opposite sides are congruent, this one's congruent to this one, this one's congruent to this one, then you're done. It's guilty of being a parallelogram. You don't need to check that they're parallel. If both pairs of opposite sides are congruent, it's already a parallelogram. If both pairs of opposite angles are congruent, then it's a parallelogram. Don't have to check the length of the sides or anything else. You're done. If the diagonals bisect each other, so if the diagonals, that one cuts that one in half, and the other one cuts the longer one in half, then it's a parallelogram. And then this last one is the only one that's going to look different from what we talked about on Friday. This is not one of the properties. This is one of the ways to prove it guilty of being a parallelogram. You can have one pair of opposite sides that are both parallel and congruent. So let me show you what that looks like. Congruent and parallel at the same time. So if you can capture one pair of opposite sides and they're both parallel and congruent at the same time, then you can say that it's a parallelogram. So, Yeji, any of these, if any of these are true, then it's a parallelogram. So you only need one of these 5 things to be true. One. Let's see if we can try it. For some reason, oh, my shapes are not showing up. Okay, just give me a second. Determine whether the quadrilateral must be a parallelogram. Explain. Is A a parallelogram? So you go to your checklist and you look at all the things on your checklist. This parallelogram has some sides marked, so you look at the one that talks about sides. That one says both pairs of opposite sides are congruent. So for A, are both pairs of opposite sides congruent? It's taking y'all a long time to answer. So, they are. These are congruent, check. These are congruent, check. So I would say yes, it is a parallelogram because opposite sides are congruent. Yes, A is a parallelogram. Now we're going to learn later it's more than just a parallelogram. It's actually a rhombus, but that doesn't matter. Is it a parallelogram? Yes, it is, because it fits that criteria that we already wrote down in our notes. Okay, next one. Is that a parallelogram? Can we prove 100% that it's a parallelogram? And on this one, the answer is no. Very good. No, because the diagonals are not bisecting each Other. They have to bisect each other. The diagonals are not bisecting each other. Next one. Is that a parallelogram? Yes, because the opposite angles, both pairs of opposite angles, check, check, are congruent. So that one's a yes. What about that one? So right now our picture does not have enough markings, right? We've got one pair of opposite sides congruent. And that's it. But what else can we add to our picture? Those are alternate interior angles. When alternate interior angles are congruent, we've got some parallel sides. Parallel, parallel. But this still is not fitting any of the criteria that we wrote down in our checklist. Both pairs of opposite sides aren't parallel. Both pairs of opposite sides are not congruent. And the parallel and the congruent markings are on different sides. Can we add anything else to our picture? So that one ended up being a no, but that was an important one to look at. You can't prove the triangle is congruent, and you don't have enough opposite sides parallel or congruent. Last one. Angle W and angle Z are supplementary. Just for fun, I'm going to put 180 because there's really no other way to mark that they're supplementary other than putting numbers there. So what do you think? Now, we've still got those alternate interior angles congruent, so we can put parallel here and here because of these. And then those 80 and 100, those are same side interior angles. And if same side interior angles, those start with an S. If they're supplementary, then the lines that make those, X, W, and Y, Z, those lines have to be parallel. These lines that make those same side interior angles have to be parallel. So dun-da-da-da, is it a parallelogram? We have both pairs of opposite sides parallel, so that one is a yes. Okay, so now we're just going to do some workout problems. Determine the value of X and Y so that the figure is a parallelogram. So we're really just using our properties. If we want to force this to be parallelogram, then we're going to force the opposite angles to be congruent. We're going to force the consecutive angles to be supplementary. So Yeji, write your answer for X, and Minjung, write your answer for Y. Very good. X is 65 and Y is 75. So we're setting these equal, and then we're adding these to equal 180, except we already know what X is. The only thing that could trip people up is if they get scared of that fraction. But how do you get rid of that fraction? You can either divide by 2/3 or you can multiply by 3/2. Okay? So you get 115, and you can take that and you can divide it by 2/3 as long as you put it in parentheses. Wait a minute. Oh, thank you. 2x, George. Thank you. I was like, that is not working out. 130, sorry. Plus 2/3 y equals 180. So that's much prettier. So you got 50 divided by 2/3, or you can multiply it by 3/2. Beautiful. Next one. Determine the value of X, Y, and Z so that the figure is a parallelogram. Helaman, you got X. Tahani, you got Y. Jenny, you got Z. Alternate interior, 39, 39. 62 divided by 2, because alternate interior are equal. And then z, okay, 79. Z, we're going to use our triangle. We've got 62, we've got 39, and we've got z, so we add them up and subtract from 180. Very nice. Too easy. Determine the value of x and y so that the figure is a parallelogram. Uh-oh, we haven't done one of these in a while. We have not done one of these in a while. 3y plus 4 equals 5x. Y plus 6 equals 4x. Do y'all know what to do here? I know. Do y'all know what to do? We need to multiply this guy by -3. So we'll have -3y plus, well, minus 18 equals -12x. And then we just add them together. -3 plus 3 is 0. -14 equals -7x. Ooh, we're lucky. Those are divisible. X is a beautiful 2. So are we okay with system of equations? You have no idea what I just did. I multiplied the second equation by -3 because I wanted to eliminate 3y. You could have also solved for y and you could have used substitution. Yep, that's algebra. So then you plug 2 in, like 5 times 2, that's 10. 10 minus 4 is 6. 6 divided by 3. Are they both 2? Are they both 2? My other 2 looks like a Z. Oh, that's what algebra at your school is doing right now, system of equations. Cool. Good thing y'all already did that. Okay, prove that MNOP is a parallelogram. So you've got a whole checklist of things that can help you prove that this is a parallelogram. You've got a whole checklist. So you can pick anything off of that checklist and use it to prove that it's a parallelogram. You can use opposite sides congruent. You can use opposite sides parallel. Which one do you think is easier? Finding the slope or finding the length? I say slope, hands down. I agree with you, George and Yeji. Okay, very good. So what's the slope of MN? The slope of MN is 0. What's the slope of PO? It's 0. What's the slope of PM? Rise 2, run 1, 2, 3. 2/3. What's the slope of ON? 2/3. Rise 2, run 3. So now we have proved that it's a parallelogram by showing that opposite sides are parallel, because parallel lines have the same slope. If the long side of a parallelogram is 3 times the short, what's the perimeter of the parallelogram in terms of x? It's a race. Go. Who's going to get it first? Ah! George, you're so fast. Oh man, that was good. Teacher knows how to do it. I just can't even write down the right numbers to save my life. Very nice.